We've just been looking at pre-built models or models that have been imported, but it's also interesting to create your models. And a good way to do this is using the graphical modeling interface of System, but sometimes you want to do it programmatically using the Wolfram language, because there's a lot of scripting that you can make use of, and the Wolfram language empowers you when you're building these models. So if you want to build like a large array with different models with variations of each other, then you can use the scripting functionality in the Wolfram language to build these. And I'll show you just how you can do that. Let's load in a representation of a low-pass filter, since we've been talking about these electrical models. So it's just a electrical model which describes the filtering, where we set the voltage, and it will have some capacitors and OP amplifiers that will in the end filter voltage spikes and so on. So it will smoothen out the voltage in this particular circuit. And we can simulate the model and see how it behaves. And previously we have used this association to change initial values, for example the balls in the previous section, or the parameter values. You can also change inputs if you have undefined inputs like this. So this is an input to the model. Then you can say, you see the name here, VI. You can say that it goes towards a Wolfram language function. So this could be anything that takes one argument time and then spits out one value. So it could be an anonymous function like this. It could be sine, the time data model, time series model, or anything like that. So here we'll just have a unit step, and we will plot the input and the output. And with a unit step is a particularly good way to see how a filter filters a signal. So we have the input, which is quite sharp, and then we have an output which is filtered, which is over here, and where the voltage has been filtered. And the first thing, if we want to create a model, one easy way to create a model is to configure a new model from a previous one. And to do this, you just call the name. You just take one of these system models. You take a bracket, and then you put an association of what you want to change in the model. So this is the same, as we do with system model simulate, but a bit more permanent, where we actually we create a new model which has new parameter values or initial positions and so on. So now we got a model assigned here called new low pass, which is a variation of the old low pass filter here. And show that they are indeed Q2 new, we can simulate both of them and plot them together. So you can actually plot models that are different models using the system model plot command. It doesn't have to be different parametric simulations. It can be different models as long as they have the same both have the same variable that you want to plot. So in this case, the VO. And when we set these parameter values in the new model, it looks like the filtering I guess you say we lowered the filtering, because now it's looking a bit, it's not filtering it as heavily. We can ask for a property from this new model that we created. We'll ask for the model name, and I'm doing this to show you that if you create a model like this, if you just create a new variation of a model, it's still it's unnamed. We haven't given it a name yet, so it's living on quite hidden in the engine. If we want to we can still find it in System Modeler if we ask for it though, but it's quite hidden among unnamed models. But if we want to promote this to something that we want to reuse later, we can give it a model name. So this will call the model new low pass, and we'll suddenly have a model here in System Modeler. I'll show you. That's called new low pass. So we just saved the model name. But it hasn't been saved either, this new model that we created. But we can do that with the export command. So just export the place you want to save it and the model that you want to save, and suddenly you have a location where it's saved. Right. Another way you can create models is to use create data system model, and that is a command that takes a time series or other time function in the Wolfram language. For example, here we have a random function in the Wolfram language, a random time series based on an autoregressive process, and we can create a data model based on this. And a data model is just a set of different time intervals with an output from from this component that we just created, this model that we just created, that can be connected to other parts of the system. But this can be simulated just like any model. So we will call system model plot. We'll ask for this output, and it's an array actually. It can have multiple values. So we'll specify that we want the first value, which in this case is just the one that we put in. Now, this isn't particularly interesting on its own, but what's interesting is that we can use this with a function that's called connect system model components. And what this will do is it works like the graphical user interface in System Modeler, where you can connect different components together and create a completely new model, but using scripting instead of graphical modeling. So we'll create a component in this model called data model, and it will refer to this system model up here that we created, the data model. And we'll create a component called low pass, which refers to the low pass filter that we created previously. Oh, not a new low pass, it's not actually the one we created. And then we'll just give a list of the different connections that we have in the model. And here we have a model that has been created from the Wolfram language, and it looks like, yes, here we have it, programmatically created and simulated just like any other model. And we can see how this low pass filter filters out the output signal coming from the data model that we created. And this, of course, can be further opened up and edited in System Modeler. So the one we just created, it lives here in System Modeler, and we can further, modify it. We can add new connections.